Welcome to class. Today we are going to be looking at differentiation from first principle. So straight away, without wasting too much time, the formula for the differentiation from the first principle is given by the y dx equals to lim delta x tends to 0 f of x plus delta x minus f of x divided by delta x. This is with the assumption that you will be given your y as f of x. So if you are given your y, for example, you are given your y as x squared, you are going to rewrite it as saying f of x is equals to x squared. So you will now find f of x plus delta x. That means anywhere you see x, you place it as x plus delta x. In this case, my f of x plus delta x will change to x plus delta x all squared. So after getting your f of x plus delta x minus, you subtract it from your x squared, which is this, then you divide it by delta x, then you take your limits. So that gives us the answer. So let's solve an example without wasting too much time. Example 1 says that differentiate f of x equals to 2x squared plus x plus 2 from the first principle. So the first thing you have to do from here is that you have to get your f of x plus delta x. So more like anywhere you see x, I'll replace it with what? With x plus delta x. So this is my x delta. I've changed to what? X plus delta x. So that will give me 2 brackets. This x here will change to what? X plus delta x. So I have x plus delta x all squared plus this x here will change to x plus delta x and plus 2. So the issue now is that I have to find a way to expand. This to expand x plus delta x all squared. So if I want to expand that, let me show you how to expand that. So if I want to expand x plus delta x all squared, by the elementary mathematics, this also means x plus delta x bracket x plus delta x. So if I expand this actually means x bracket x plus delta x plus delta x bracket x plus delta x. This is elementary expansion, and this will give us x squared plus x delta x plus x delta x plus delta x all squared, and this will give us x squared plus 2x delta x plus delta x all squared. So all of this is the expansion for this. So I will substitute that here. So that will give me 2 bracket. So here that we have x plus delta x all squared. So the expansion that I got here is this: x squared plus 2x delta x plus delta x all squared. Close the bracket. Then here, this is plus bracket delta x plus x. So I'll use this plus to remove the bracket. So I'll have plus x plus delta x, then I have plus 2. So my final expansion here will be 2x squared plus 4x delta x plus 2 delta x squared plus x plus delta x plus 2. So all of this is my f of x plus delta x. So let me call that one 1. More like equation 1. So let me call that one 1. Then don't forget that our f of x was also given as what? Our f of x was given as 2x squared plus x plus 2. So I'll go and use the formula now. What is the formula? You can see it on the screen. the y dx is equals to lim beta x tends to 0 f of x plus beta x minus f of x over beta x plus, let's recall the formula. Let's recall the formula. Let's recall the formula. Recall that dy dx is equals to limit beta x tends to 0 f of x plus beta x minus f of x over beta x. So what that actually means is that I'm going to substitute this one. All of this one is my f of beta x. So I'll substitute this, substitute all of this one as my f of beta x. So let's go. And I'll substitute, okay, let me call this one 2. I'll substitute 2. I'll substitute 2 here. I'll substitute 2 for my f of x. And my f of x is 2x squared plus x plus 2, x plus 2. So let's go. So my f of x beta x is on the screen here. They are all, I'm sure I'll write everything. So they are 2x squared plus, okay, let's write that here. 2x squared plus 4x beta x plus 2 beta x squared plus x plus beta x plus 2. See, all of this one is my f of x plus beta x. This is it. Then minus, open a bracket, f of x is this, is it here. Everything here. So open a bracket, 2x squared plus x plus 2 divided by beta x. So at this point I can continue to at this point I can continue to, I can now expand. So what I have here is 2x squared plus 4x beta x plus 2 beta x squared plus x plus beta x plus 2. If I remove the bracket of this minus, I have minus 2x squared minus x minus 2 over beta x. So I can cancel out now. Let me cancel out. So if I cancel out, I will see that 2x squared cancel 2x squared. And I will also see that plus x cancel minus x. And I also see that plus 2 cancel minus 2. So I'll be left with let's pick up what I'm doing. So I'll be left with 4x beta x plus 2 beta x squared plus beta x. I'll be left with this, then divided by beta x. So what I will do at this point is that I will factorize. The factorize beta x is here, beta x is there, beta x is there. So beta x bracket 4x plus 2 beta x, remain 1 of beta x plus remain 1 here divided by beta x. So at this point I will divide, cancel divide. So this cancel this. So I'll be left with what? 4x plus 2 beta x plus 1. Don't forget to, at this point, after I've simplified everything, that is why I will take my limit. Don't forget that there's a limit here. Look at this limit here. Limit x tends to 0. So I will take my limit now. So you take your limit after you have simplified everything. We made a video on limits. You can check our page for a video on limits. We actually solved 10 examples on limits. So we explain the concept of limits. After limits, like after you have finished simplifying all of the expressions, then you put your value of the limit. So in this case now, our limit is lim delta x tends to 0. So our final answer will be 4x plus 2 bracket 0 plus 1. Then our final answer will be, our final answer is now what? 4x plus 1. So therefore, dy dx is equals to 4x plus 1. That's that for that question. So this is using first principle. So you can always check your answer. Don't forget the shortcuts. Don't forget the general formula. General formula is if y equals to ax is power n. But dy dx is what? N a x n minus 1. So if you have differentiated 2x squared plus x plus 2 from the beginning, our answer will have been what? 4x plus 1. So because if you differentiate 2, you have a constant, you have 0. So this is the answer. So you can see that we have the same answer. You know that the instruction says that differentiate from the first principle. So that's why you have to go through all of this. So if the instruction was not there, I would have used my general formula and get the answer. But anyway, you can also always use the general formula to see if you are right or wrong. So let's go to example 2. 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 Example 2 says that differentiate f of s equals to 1 over s squared plus 1 from the first principle. So what I'm going to do from here is the same thing. Get your f of x plus delta x, and that will give us 1 over, open the bracket, x plus delta x all squared plus 1. So I will keep that. I won't expand it. Don't let me expand it so that I don't complicate the whole issue. Don't forget that our f of x is this. So by now I should understand what I mean by f of x plus delta x. Times anywhere I see x, I put x plus delta x. So this is my x here. So it's going to become x plus delta x all squared plus 1. So we call the formula. We call the formula. We call the formula. What's the formula? We call that dy dx first principle. The formula is the limit the x tends to 0 f of x plus delta x minus f of x divided by beta x. So my f of x plus delta x now is now 1 over x plus delta x close bracket square plus 1. All of this is my f of x plus delta x minus f of x is its equation 1 over x squared plus 1 divided by delta x. So I can as well write this as write it as 1 over x plus delta x all squared plus 1 minus 1 over x squared plus 1. Let me put all of this in the bracket divided by delta x. Okay, so let me do the one in the bracket first. So that will be 1. Okay, let me find the LCM of the one in the bracket. If I want to find the LCM of what I have in the bracket here, if I want to find the LCM, let's do like this. our LCM will be, let me put this in a big bracket, in a square bracket, more like x plus beta x all square plus 1. Then also this in the bracket too, x squared plus 1. So if this goes in the LCM, it will remain, if this goes in this, it will remain this. So x squared times 1, so I have x squared plus 1 minus, if this goes in the LCM, it will remain all of this, remain all of bracket x plus, we know what you have on the left here, so it remain bracket x plus beta x all square plus 1. Let's put that in the square parenthesis. And this is divided by delta x over 1. So that will obtain 2 times 1 over delta x. Okay, so uh so here we have x squared plus 1 minus, open the bracket. Let me expand this one in the delta x plus delta x all square. We have done this before. We have done the expansion here. The expansion here is actually x squared plus 2x delta x plus delta x squared. You can check above for the expansion. We have done that before. Then plus 1 divided by, let me still put in square brackets, divided by x plus delta x all square plus 1 square bracket, then bracket. I can change this one to another bracket now. X squared plus 1, then delta x. I put the delta x. So if I expand what I have in the numerator, if I expand what I have in the numerator, we have x squared plus 1. If I expand this, I will have minus x squared minus 2x delta x minus delta x squared, then minus 1 over delta x bracket square bracket x plus delta x all square plus 1 plus the square bracket, then this x squared plus 1. I have my reason for not expanding the down part. I don't want to complicate it. Well, I expanded the up part so that I can easily cancel it. So you see that at this point I can say that x squared cancel x squared plus 1 cancel minus 1. So I'll be left with minus 2x delta x minus delta x squared over what? Delta x bracket square bracket now x plus delta x all squared plus 1. This is square bracket, then this is another bracket x squared plus 1. The square bracket is like a bigger bracket that holds another bracket inside of it. So so if I factorize the up part, I have, if I bring delta x out, delta x bracket minus 2x minus delta x divided by what you have at the numerator, divided by that, divided by this, divided by delta x bracket, and put my square bracket x plus delta x all squared plus 1, then bracket x squared plus 1. So this can cancel this. So this can cancel this. So I'll be left with minus 2x minus beta x over, so I can use a normal bracket now. Okay, let me see, use square bracket. Square bracket x plus beta x square plus 1, then s square plus 1. So at this point that I've simplified, I can take my limit as, let's take our limit, lim beta x tends to 0. So if I take my limit now, I have minus 2x minus 0 over square bracket, open square bracket, x plus 0 square plus 1 square bracket, then I have s square plus 1. So my final answer here would be what? So my final answer here would be, so therefore my final answer here will be dy dx is equals to minus 2x over, so it remain s squared plus 1 here, s squared plus 1. And that will actually give us minus 2x over bracket s squared plus 1 s squared. Or you can say your answer is minus 2x bracket s squared plus 1 is minus 2. So that you stop there. Stop there. So this is the answer. This how to differentiate this from the first one. So you can actually use this question. So you can check. This one is y equals to 1 over s squared. So you can actually use chain rule to check your answer. So let's check. Let's check if what you have is correct. This will give us the same as saying s squared plus 1 raised power minus 1. So if I use my chain rule, this is a chain rule, composite function. Although I was able to make a video on this later. So if I use my chain rule, write the power first minus 1, differentiate the quantities in brackets 2x, then repeat all of this s squared plus 1 minus 1 minus 1, and that will give us minus 2x brackets s squared plus 1 minus 2. So we're actually correct. So that's that. So you can go to the video over and over again to understand it. So that's how to do differentiation from first principle. So this is where we stop our video for today. See you in our next class.